computer. Let's share screen. All right, so let's see. This works. Is this the version that you took, Ian? Do you have this first question?
Let me pull it out real quick.
Yeah, 1/3 and 2/3.
Yeah, that's the one.
Okay, yeah, I forgot which one it is. All right, so for this question, let's start by writing out the terms. So when n is 0, what this becomes is, when n is 0, you get 1/3 times 2/3 to the 0th power. Well, what's that? That's 1/3 times 1, because anything to the 0th power is 1. So 1/3 is the very first term. Okay, therefore, you can say that this is equal to 1/3 plus 1/3 times 2/3. That's what happens when n is 1. And then the next one will be 1/3 plus 2/3 squared. Next one will be 1/3 times 2/3 to the 3rd, and so on. Right? So once you write in this format, you see that this is, what series is it? Anyone?
Geometric, right?
Geometric, yes. So because this is geometric, with the very first term being 1/3 and r, the common ratio, being 2/3, because every time you move to the next term, this 2/3 is multiplied, and therefore the solution is you have a over 1 minus r. That's the formula for infinite geometric series. So I should say this is equal to a over 1 minus r, where a is 1/3 and r is 2/3, and that is 1/3 divided by 1/3, and that's a little hard to see. Let me see. 1/3 and then divided by 1/3, so that anything divided by itself is 1, right? So that's the answer. Okay. I think most people figured this out. The common mistake was some people didn't realize that the first term is 1/3. I guess they didn't pay attention to this 0. If this started from 1, then it would have been 2/9, and I've seen a lot of people using 2/9 at the very first one. And another common mistake was like not being able to figure out the a over 1 minus r. Like some of you forgot this formula. Any questions? Feel free to stop me when you have any questions, okay? All right, so the second one is about telescoping series, where you turn this into a telescoping series by multiplying by the conjugate, right? Take the bottom and you multiply by the conjugate. And because this bottom thing is same as a squared minus b squared, it's a plus b times a minus b, and that becomes difference of 2 squares, right? And that turns it into n plus 1 minus n plus 2, which is just -1. So this is what we get. We see that this is now equal to bottom, after multiplying the conjugate, the bottom turns into -1, so that this is same thing as just dividing by -1 is the same as multiplying by negative. So that's what we have. And you can also pull the 2 outside and multiply the negative inside. So what I'm going to do is I'm going to pull the 2 outside, but then multiply the negative inside so that this is negative and this is plus. Okay. Now let's try to write this down. Well, we have the definition of an infinite series is the limit of the partial sum, right? So we're going to take the limit of capital N going to infinity of this sum, where now the top is replaced by capital N. And that gives you, if you start writing out explicitly what that is, when you plug in 2, that's negative square root of 2 plus 1 is 3, and plus square root of, when 2 is plugged in, 2 plus 2 is 4. That's what happens when n is 2. Plus, the next one would be exactly the same, except these increase by 1, right? And then one more. Let's write down 5 and then 6. And then you keep going until the very last one, when capital N is plugged in, it'll be exactly the same as this one, except that instead of small n, you would have capital N. Supposed to change. Okay, well, anyways. Oh, I see something here. All right. So now, if you see this, you see that some things are canceling. So you see that 4 and -4 will cancel. So these two will cancel. And then square root of 5 and square root of 5 will cancel. And then square root of 6, and then eventually something will cancel here, and then something right before this will cancel with this one, right? And therefore, after the massive cancellation, so after canceling all that, you're just left with negative square root of 3 would be the one that doesn't have anything to cancel with, and this one also doesn't have anything to cancel with. So these are the survivors after all the cancellation. And then when infinity is plugged in here, you get infinity, which is same thing as infinity, right? Or if you want to write a little bit more, you can say this is infinity, and that will be again infinity. So infinity is the correct answer to this second question. Let's see what's the next one. Okay, here. Okay, I think this is the one that most people got right. I made the partial fraction easy enough that at least some people can get some credit. So you factor the bottom, which gives you x plus 4, x plus 1. And now you have to do partial fraction expansion. A over x plus 4 plus b over x plus 1. You multiply the denominator both sides, so when this is multiplied, you can see that these cancel out. These cancel out. And then these cancel out. So that the end result after canceling, you get x plus 6 equal to a times x plus 1 plus b times x plus 4. Okay, so what do we plug in? X equal to, anyone? You guys are so quiet today. No one, okay. All right, usually in class, you guys know what to do, but okay. When you plug in x equals to -1, you get 5 on the left side, whereas you get a times 0 plus b times 3. So that you get b equals to 5 over 3. On the other hand, if you plug in x equals to -4, then the left side becomes 2 equals to a times -3 plus b times 0. So that a is equal to -2/3. Okay, so as a result, we have this a as -2/3. Let's put it in here. And b as 5/3. Which means that if you have the integral of this, that's the same thing as integrating this. Okay. And that's same thing as, this one. Okay, so this thing now splits into 2 integrals, and you can also pull out -2/3 outside. So put 1 and then put -2/3, and pull the 5/3 outside. And therefore now you can do these integrals. They're both f prime over f type, so their integrals are just ln of the denominator. So I just say ln of the absolute value of x plus 4. And this would be ln absolute value of x plus 1. And plus c. So that's the final answer. Okay, that one most of you got right, so I don't think you're going to have much questions. Let's move on to question 3. Right, this one. Surprisingly, many people couldn't do this. I solved similar questions twice in class, so that was a bit disappointing. All right, so first of all, you have to know that at x equals to -1, this thing inside, this function, is undefined. Therefore, this integral should be broken into two and then be computed using improper integral. Okay. Here. Should be broken into. Okay. All right. So now we have to say, therefore, this is equal to this plus this, where the first one integral should be -2 to -1, and the second integral from is -1 to 2. So break up like this, and because this -1 is a problematic integral, you have to rewrite them as limits. So you should really put an a there with the limit of a going to -1 from the left side. And then this one would be limit of b going to -1 from the positive side, where by b I mean this lower end. Okay. So now we've turned them into improper integrals and turned them into limits. Now we're ready to do the calculation. Note that integral of 1 over x plus 1 squared dx is equal to integral of x plus 1 to the -2 power dx, which is same as x plus 1 to the -2 power, but then you add 1, so that gives you -1, and you put the reciprocal of 1 over -1 plus c, and that's equal to -1 over x plus 1 plus c. Okay, so using that, now we can compute this by using the above result. This one is really, this is the antiderivative, right? So we put that in there. And that's true for both cases, for both integrals. I'm going to rewrite this. And then I have to put a bar. Okay, and from -2 until a for this one, and then this one is from b until 2. Okay. Now let's proceed by computing this limit. This one means that you have to first plug in a in here. A goes in here, right? So that's what you get when a is plugged in. Minus, and next time -2 goes in here, so it's the same thing, but x is now replaced by -2. Okay. Again, this one, 2 has to be plugged in there. So 2 replaces the x, and then minus this, you have to subtract, and b replaces the x. Okay, and then When -1 minus replaces a, let's see what that gives us. So a is -1 minus, and then for b is -1 plus. B is -1 plus. All right, so let's simplify a few things here. This is -1. This is +3. Okay. And we have to figure out what this one is. Can anyone unmute and tell me what this value is?
0.
Oh,
It's 0, but it's slightly less than 0, right? Yeah, because this one means slightly less than -1. So this is more like -1.0001. So what you get is something slightly less than 0. And because of that, if you have 1 over this becomes 1 over 0 minus, and if you divide 1 by a small negative value, that becomes really big negative value. So that's what you get, and therefore this part right here would be -infinity. Now in the same way, well, let's include the minus sign as well. Minus. This will be minus of -1, -infinity, which is +infinity. Okay, so in the same way, if I take that much, this one will be, this bottom here, this time will be 0 plus. And these two negatives will cancel each other, so you're just going to be 1 divided by, you're just going to get 1 divided by 0 plus. And because positive divided by positive is positive, this time we're going to get +infinity. So that tells us that this value is equal to, the first one is infinity, and the second one is -1, third one is -1/3 plus infinity. And therefore the answer will be infinity. Okay. All right, if there is no question, let's move on to the next one. Find the limits. If you use L'Hopital's rule, you must indicate whether this limit is 0 over 0 type or infinity type. Okay. This one, you use the fact that e to the power of ln cancels. So you can rewrite anything as e to the power of ln of that thing. Okay. Maybe I should put parentheses around here so that people aren't confused. Okay, so this entire thing is inside the log. Now we also know that if you have anything inside the log as an exponent, they can jump out of the log like a frog over the log rule, so that this can be written as 1 over 1/3 will replace 1 over 1 over 3x. Yeah, this one will replace, will be in front, and then inside you're just going to get 1 plus ln of 1 plus 2x. Okay, and because if you multiply a non-fraction to fraction, it gets multiplied to the top. This thing is same thing as this, just the log just being in the top, okay? Ln of 1 plus 2x divided by 3x. Okay, so that's what you get, and since ln of 1 plus 2x, 2 times 0 is ln of 1 equal to 0, this limit right here is 0 over 0 type indeterminate. So we can use the L'Hopital's rule to get, which means you have to differentiate top and bottom, right? So we differentiate ln, we get 1 over 1 plus 2x, but then you have to multiply by 2, and if you differentiate 3x, you just get 3. Okay, and then maybe I should say right here, this right here is a chain rule. Okay. Now nothing's stopping me from plugging things in, so I'm just going to evaluate this as 0. I just plug in 0. And if you plug in 0, that's just 1 over 1, right? So that gives you just 1 over 1, which is 1. Which just becomes 2/3. So the answer is e to the 2/3. This next one is 0 over 0 type. So we use L'Hopital's again. And therefore we get this differentiate e to 2x. If you differentiate, 2 comes out. 2x differentiates to 2, and minus 1 is a constant, so that goes away. It's 2x. Okay, and I was surprised that a few people forgot this 2 right here, which again is from the chain rule. Okay. Now again, this is 0 over 0 type indeterminate. You can verify that just by plugging in 0. Okay. So now we have this again differentiated. You differentiate the top and bottom, and this time it will become 4. Negative 2 will go away, and this will just give be 2. And then you plug in 0. Oh, we don't need that. We just have just 0. Which is just 0. And that gives you just 4 over 2, which is 2. So 2 is the answer. Okay, find the Maclaurin series of this and also write your answer in sigma notation. Well, you have two ways to do this. Either you can use the formula I wrote in the beginning, which is sum of n equals to 0 to infinity of x to the n, which is like 1 plus x squared plus x cubed plus da da da, equal to 1 over 1 minus x. Or you can also use the a over 1 minus r, because this formula comes from a over 1 minus r. So that could have been another one. Now, observe that if x in the 1 over 1 minus x is replaced by negative 2x squared, then it becomes what we want. It becomes this thing. Okay. So what you now know is I replace x by negative 2x squared. So this just replaces all the x's. Okay. And the end result is that the right side, let me see. Well, this is the same thing as negative 1 to the nth power 2x to the squared to the nth power, so it's 2nth power. That's what you get on the left side. Or maybe I should spell it out. Let me just spell it out. Squared. Okay. So see what I did? I just broke apart the negative 1 outside, because negative 1, it has the nth power applied. I just wrote that negative 1 to the nth power. Okay. And everything else is the same. While on the other hand, the right side, if you look at the right side, after canceling the minus with minuses, this minus with minus is just plus, right? So you end up with just plus. So minus and minus cancels, and you just get plus. So this is like the Maclaurin series, except that you really want to write it as some coefficient times x to some power. So although we have almost an answer in front of us, let's continue to work on this. So these two multiply, right? So that means it's like 2x to the 2nth power by using the fact that these two numbers multiply. And then you also know that when you have exponents like this outside, that gets applied to each individual things, right? So that's what you get after applying the x to the 2. Applying the 2n power separately. And that's it. That's the answer, and it has the form of some coefficient times x to the 2n. So let me change the color of just the front part so that it's easier to see what's going on. So this part is the coefficient, and that's x to some power. So it's a power series. So that's the correct answer. Now there was a bonus question, and sadly nobody got this. So I was a bit disappointed. I gave like maybe 1 point to somebody who was kind of getting it. But it's like this. So if you compare the above formula with the formula a over 1 minus r, then a is 1, and r is negative 2x squared. Okay. Now we know that a over 1 minus r is the converging value of the geometric series only when absolute value of r is less than 1. Okay, so that's something that we talked about before, right? So what that means is that the absolute value of this has to be less than 1. But wait, 2x squared is a positive number, so negative 2x squared is a negative number. If you take the absolute value, you just get the positive portion. Right? So this is what you're saying. And for this to be true, if 2x squared is less than 1, we know that 2x has to be between 1 and negative 1. So we know that negative 1 and 2x 1. Right? Because if 2x is greater than 1, of course, 2x squared will be greater than 1. The only time when something is, if something squared is equal to 1, then that thing must be either negative 1 or 1. And therefore, if you insist that that's less than 1, then that thing inside the square must be between the two values. So that's what we have, and therefore you have negative 1 over 2 less than x less than equal to 2. So that's the premise. That's the correct answer. Which means that this formula here would agree with this value only when x is between negative 1/2 and positive 1/2. And sadly, if your x is bigger than that, then this will fail to converge, and that will have nothing to do with this function. Okay? Okay, so find the Taylor degree 3 Taylor polynomial of f of x equals to sine x centered at c pi over 6. I think people who didn't get this right didn't understand what Taylor polynomial centered at c equals to pi over 6 is. It means that you want x minus pi over 6 like that, and then for the next one, a2 x minus pi over 6 squared plus a3 x minus pi over 6 to the third power. Okay. And by Taylor polynomial, it means that you first think about the Taylor series of sine x, expand it with center at pi over 6, but then you truncate it at the third degree. That's what it means. So you have this, and now you start plugging in values to find out the values of a0, a1, a2, a3. Okay, so what should I plug in both sides? Anyone? X equals to pi. I just wrote it before I asked getting the answer. Okay, so x equals to pi over 6 will make everything go away except sine of pi over 6 equal to a0. Right? Okay, this one I'll ask. What's sine of pi over 6? Somebody from audience. What's sine of pi over 6? Okay.
1/2.
0.
1/2. Okay, 1/2. Sine pi over 6 is 1/2. Yes. So you have a0 equals to 1/2. But then you take this and you're going to differentiate both sides. So we're going to differentiate the left side and differentiate the right side. And the end result of that derivative is you get cosine of x on the left side. A0 goes away, A1 will by itself because this differentiates to 1. Then A2 times twice of this thing plus A3 times 3 times this thing squared plus da da da. Okay, and again you plug in x equals to pi over 6 both sides so that you get cosine of pi over 6 on the left side equal to A1. And because cosine pi over 6 is radical 3 over 2, that's the value of A1. Okay, and then you take this one and differentiate both sides again. Differentiate this one, which gives you negative sine of x, and on the right side you're going to get just 2a2 plus, see 2 will come down, so 2 times 3 will be 6, so you get 6a3 times x minus pi over 6, da, da, da. And again, you plug in x equals to pi over 6, both sides, so that you get negative sine of pi over 6 equal to 2a2 plus 0. So that says that negative 1/2 is 2a2, which means that if you divide both sides by 2, you get a2 equals to negative 1/4. Okay, and just one more. Differentiate both sides again. And that gives you negative cosine of x equal to 6a3 plus something a4 x minus pi over 6, and then plus da, da, da. So everything will have x minus pi over 6 still, so that again if you plug in x minus pi over 6 both sides, the only survivor will be 6a3 on the right side. So therefore you get negative cosine of pi over 6 equals to 6a3, which gives you that negative square root of 3 over 2 is 6a3. And then if you solve this for a3, then you get a3 equals to negative square root of 3 divided by 12. Okay, so we got a0, a1, a2, a3. But if you stop there, then you don't get the full credit. You have to write the sum. So that's a1. Okay, then a2 is this. A3 is this. So that the Taylor polynomial of degree 3 of x would be this thing here, truncated at the 3rd degree, but all these a0, a1, a2 will be replaced by what we found So that's the final answer. Okay. And this truncation will be a good approximation of the sine x function near pi over 6, or the 30 degrees. And that's it. That's all. Yeah. So it wasn't a long exam, so just ended. All right. So because that's all I've prepared today, I guess we have a short class today. I will send out this solution to everyone so you guys can review it. So that's all for today. Bye.
Thank you.
Bye. Have a happy Thanksgiving.
Have a good Thanksgiving.
Yeah, all of you
Happy
have a
Thanksgiving.
Thanksgiving. Bye bye.